Welcome everybody to the session. As stated on the slide there, use the Cloud Pak for integration, and specifically it will be our API management capability within that Cloud Pak to define, socialise and manage consumption of Kafka events. And so what I'll be speaking about today is a new set of capabilities within the Cloud Pak for integration, and we call this Event Endpoint Management, or EEM. And what we're really talking about here is extending the principles of API management. And so, but in the asynchronous API domain. And we'll talk more about what that is and what it means and what considerations there are for actually doing this sort of thing. And so it's a new and emerging space. So, but it's being driven by a resurgence of things like EDA, event-driven architecture within organisations. It's been around, that sort of technology has been around for a long, long time. But as I say, there's a recognisable resurgence in a lot of organisations now. There's a broadening use of technologies like Kafka, which is why we're kind of focusing on Kafka today. And we'll look at how this kind of fits in with managing and modelling APIs that you're doing today, and why it's important in an overall integration solution to consider the events as APIs. So I thought I'd start off with something absolutely non-contentious. So everyone here is going to look at that and go, well, that's probably a synchronous REST API call. Is that fair to say? Everyone comfortable with that? Okay, so now what I'm going to do is that. And so you're probably looking at me and there's probably a couple of people shuffling in their seats going, what's this guy doing? And for those of you streaming live and for the YouTubers after the event, do not adjust your screen. So what I'm talking about today is actually turning the API on its head. And that's what we're going to try and do. And that's kind of the theme of the talk. But in a sensible way, in order to actually manage APIs and then consider the fact that we're actually dealing with events now instead of, or indeed in addition to, RESTful interfaces. And so that's kind of where we're going to focus. Before we do that, just a quick recap on interaction patterns. And I won't spend a lot of time on this. I think everybody in the room will be fairly familiar with this material. But why events alongside APIs? So let's talk about the way that two applications interact, and the first, sorry, at the top of the slide there you've got application 1 and application 2. There's a request action, so this might be a synchronous invocation of an application at the back end. It's where perhaps looking at fulfilling a request, updating a database, taking some information from that back end. But we do that in a synchronous manner. So there's a request and there's an acknowledgement. So that's the basic pattern of a regular old API. And sort of extending that now into the request state pattern. So again, the application can say, well, I want to know the state of my bank account, for example. I want to know the state of a particular order in a system. What stage is it at? And then I want to create an API for that. So give that to my customers. And so again, that kind of fits the request response pattern. You can go and sort of poll that that service at any particular point in time, and so we get the latest state of that. And now what we can also do, of course, is if we want to know the state of something, we can sort of turn everything, as I say, the theme of today is turn everything on its head and say, well, actually now what I want to do is I want the system to tell me when things change. So I want to know when an order status changes. I want to know if the order's fulfilled. I want to know if my bank account's gone below a certain amount over time, and so that there's somebody out there using my credit card, for example, that I haven't authorised. So I want to know when things change, and so that request state can be then pushed rather than pulled from that application, and we can even keep a cache of that. You can see on the left-hand side there, there's a little cylinder there that represents a cache of events. I can sort of query that cache instead of actually querying the application at the back end, and so I can sort of relieve some of the interactions with that back end, which I don't have to govern anymore. because I know that that backend is going to push me the information as well. And then the last pattern of notifications down the bottom is, of course, very similar. That's kind of telling me now when something's happening. So instead of me invoking a web service or a RESTful API to say, well, I want the latest state of my, I don't want my account balance, or I want to know when something's happening on my account, or I want to know when something changes, something happens. So instead of a transaction occurring on my bank account, I want to know if a transaction occurred. And so I'm not invoking the transaction, I just want to know something about it. I want to know when it happened, how much was the amount, and which geography maybe that transaction came from. So I can then track things like fraud, for example, and be told when these things are happening. So that's kind of the last interaction pattern that we'll talk about. But that's really the foundation now of what we're going to be talking about for the rest of the session. Excuse me. Just talk a little bit about boundaries, application boundaries. If you were in the IBM talk yesterday, which was entitled, Everything is an API, but not all APIs are equal, when we would have talked a lot about application boundaries. And so, the exposing of services outside of an application boundary. So you can see there's a lot of microservices perhaps in the top set of diagrams there. Not every microservice you can see is actually being exposed. The API symbols, the little round circle, and then the arrow represents the fact that we're managing an API at the application boundary. But you can see that some microservices are just communicating internally within that application, so we don't expose those. We don't really treat them as first-class citizens in the API management space. But the important thing to note here is that what we can consider is the fact that we now can think about not just treating the RESTful APIs as first-class citizens, but also the events. So we might want to interact with those events in a similar way to how we interact with APIs when we're going through the API lifecycle. We're defining an API. We want to talk about that in a manner that is consumable by everyone, understood by multiple tool sets. And so we might look at a specification for actually doing that. And so luckily there is one that we'll have a look at in a minute. And so at the application boundary, again, we just enforce that point again in a minute, that's where we're going to do that. So we're going to look at events and treat events and synchronous APIs as equals in that regard. So let's see what this means, really. Okay, so there's breaking it down, I guess, into four main areas, and you want to be sort of clear about the fact that we're going to be pretty agnostic in terms of when we talk about this as to what transport we're using. We're talking about Kafka today specifically, but by no means should we be focusing on any specific transport necessarily, because we want to treat events as much as possible, regardless of the protocol upon which they're being delivered to us, as similar. And so we want to describe them the same way, necessarily in that same document that might be an open API standard, for example, and look at how to describe them, how to make them discoverable, and then also not rely upon a central team necessarily to get us the information that we need about those events. So when we're considering consumption, we might have to go and talk today about why where do I find that? Where do I find that event? It's in my organisation somewhere, but I don't know. I have to find out who to talk to. I have to go to a central team maybe who's managing that to get the information that I need to connect to it. So if we just talk about the describing of events initially, if you're familiar with API management, then you're certainly familiar with the Open API spec. And so what that does for us, it tells us about things like the structure of an API, more informally how to use it, who to contact, where to get help when I'm consuming that API, if indeed the documentation is there and the developer's done a good job providing that for you at the consumption point, which is the portal. Versioning of the API is very important, of course, and also how to invoke it. How do I call this API? What's the schema for that? Where are the endpoints? Do I need some security credentials? Generally, the portal will give you that information. And so, equivalent to that specification, that Open API specification, is something we call the Async API specification. So, quick hands of who's had a look at that, or at least encountered it, or seen it in any way, shape, or form? Okay, all right, well, that's good. So at least we're giving you some fresh information here. So so it's a separate project, but it's an extension of the Open API standard. And so because it's a little bit more complex in terms of because we can support a number of different protocols. So things like, I'm going to talk about things like MQTT or webhooks, for example, as another candidate. Or the MQ protocol, for example, IBM MQ. So that's probably I'll just give this away as a little bit of a snippet. It's probably the next protocol that IBM is going to focus on in terms of making that available as an API to consume through an API management layer. We've implemented the Kafka, delivered the Kafka implementation. So you'll see that in a minute. But that's kind of where we're looking for in the future. So it's an interesting specification, Async API, just Google it, have a look at it, and maybe make yourselves a bit more familiar with it. So making events discoverable. The biggest challenge that we're told about today is not connecting to, say, an event endpoint within the organisation. It's usually you find the right person, as I mentioned earlier. It's a technical discussion that you have, and you're given the information. You go away and you code against that, and then hey presto, you've got some working samples. And so that's kind of the trivial piece. But actually finding that person, having some sort of central place to discover the events, instead of having to go and do all that sort of manual interaction. It's always good, of course, but sometimes we just we want a bit more convenience. And so, we want to, effectively have a single portal in which we can go and discover not just our RESTful APIs, but alongside them, our asynchronous APIs. So again, we're treating them in exactly the same way, and we'll see this throughout the session, I hope. And so whether it's GraphQL, SOAP, REST, or indeed a Kafka event, we're talking about them all at the same level. Decentralized access, very important. What that really means is that we're kind of making everything in a way sort of enabling people to use the event. So we're not just giving you access in terms of discovery, but then we give you information about the event. We deliver that through something like a developer portal, for example. And so that means that that's sort of powerful in a way. It gives you a mechanism by which you're pushing those events out, you're pushing information out, and suddenly everyone's got access to them. But what you also want to do is put sort of guardrails in place, I guess you'd call them, to make sure that by doing that you're not actually exposing the events. Exposing the events. That's a bit of a catchphrase, but you're not exposing your back-end systems generating those events necessarily to either malicious attempt or just oversubscription, for example. And you're also not exposing, very importantly, the credentials that system uses to connect to. You want to be decoupled from that. Okay, and so decoupled systems. So the final area to talk about is, in fact, decoupling. So not just making the events available necessarily, but giving some other services to those consumers. And we might think about things like data transformation, for example, and enriching. And so you might do that as part of that exposing of the service. You might do some protocol translation. So we're talking about here today Kafka and Kafka in terms of what we're exposing. But you might want to think about something along the lines of, well, I'm publishing on a topic, and so I want to make that topic model is available in QTT, it's available in Kafka, it's available in MQ, it's available in AMQP. So these are sort of the protocols that supports. So why wouldn't you potentially look at doing some sort of translation of those protocols, if indeed it's important for some consumers who only have a certain maybe set of technology skills, for example, or just have a programming model that one that they prefer in terms of protocol consumption. So you give them that translation capability. And then connectivity or interface versioning, very important. Sorry, before I jump to the last one. So interface versioning of the events and then the event interfaces. And so making sure that if things change, you are able to release a new version of that particular specification. And so then managing exactly the same way as you can manage an API in a RESTful scenario, for example, managing that event endpoint as well. And finally, connectivity, anything that kind of points back to the protocol translation point somewhat. And so being able to not necessarily force a consumer of your API, your Async API, down a particular technology path. And so give them that flexibility to, well, I want that event, but I want it over this protocol, for example. Excuse me. So this is a journey, okay, we're talking about here. There's some things to think about on that journey. So, and some steps that you kind of go through, which are outlined on the screen there for you. But we want to first of all sort of catalogue what we have. So we need to sort of build that catalogue of the events that we're going to manage, and obviously make them discoverable. So we do that using an API mechanism, API management mechanism, called publishing. And so that's the first thing they can do. And so see those API endpoints in a portal, for example. And so sharing of interfaces. So sort of step 2 is that self-service access. So just giving them access to those events through a portal, so they can sign in, they can register with that particular developer portal. They can then discover the APIs, create their application, and then create a subscription if indeed they want to consume that API. And that interaction with the portal will give them some credentials, and then they go ahead and invoke that. We'll see that in the demonstration straight after this. And so then the third point, I guess, to consider then is we need to put some control around what we're exposing. And so we publish those events to a gateway. And so that gateway then understands that this is not a synchronous API call, not a RESTful call, it's an async API. And so that gateway then needs to understand that protocol, which makes sense, right? So that's kind of, that's the point at which we also apply the guardrails. So we're applying security policies. We're making sure that the necessary TLS certificates are being exchanged. If we've enforced mutual TLS, we make sure that there's an API key and secret being supplied with that connection. We might use that API key and secret in a slightly different manner to what you might think, in fact, and you'll see that during the demonstration. We might map that back to some other credential that, in fact, we're using in the API that's actually calling the gateway service. And so we might sort of map them back to a username and password that the Kafka API understands, and not necessarily force the Kafka API that you're using to sort of morph to the paradigm that we're actually using to expose that event. That makes sense. We'll probably cover that a little bit more in a moment. And then the externally facing portal allows you to then even offer those events beyond the enterprise, which right now for Kafka is a little bit difficult, as you'd probably expect. Okay, you don't really have, unless you've built something yourself, you don't really have that gateway mechanism to enforce policies, to apply plan rate limiting, and we'll talk about rate limiting in a minute, because that's kind of a paradigm that doesn't quite fit with event consumption. But you might want to put some other guardrails around filtering of events based upon certain rules that you want to put in your gateway for certain consumers and certain groups of consumers, so that you're controlling exactly what you want to control and applying the policies that you need to apply to actually make that API safe for your organisation. Right, so enough of the slideware. We're going pretty well with time, actually. So this will be a demonstration of the self-service for developers theme through an API portal. So what we're going to do today, what I'll show you is, first step will be an API developer. So we're going to put the API developer hat on, and we're going to create the Async API from scratch. Okay. And that API developer will expose a Kafka event source. We're going to define an Async API using the Async API standard in the API Connect, IBM API Connect product, which now supports that particular standard, version 2.1 if you're interested. Second step, as the API developer will publish the Async API via the API manager. And so that will appear both in the event gateway as a service which can be listened to, not invoked, but listened to. Okay, an API that can be listened to, and also make it visible in the developer portal for consumption, self-service consumption. Then we'll change the role, so we'll go to the application developer on the left-hand side of the screen there, who's actually building an application, maybe on for a mobile device or web page or whatever it might be, to consume the API. So they'll log into the developer portal and discover the API, and then read about it, see what is involved in actually consuming it, and then go ahead and test it. And so they'll be interacting with both the developer portal, and the application will then only interact with the business data. Is that fairly straightforward? Excellent. So let me switch now. We're going to switch views. We're going to use the Cloud Pack for integration user interface temporarily, or briefly, I should say. And we're going to also use the API Manager interface. We'll look at that in a moment. Sorry, there we go. Right screen, thank you. So we're logged in here to the Cloud Pack for Integration UI. So it's what we call the navigator. So every Cloud Pack capability, including API Connect that you deploy, the instances are able to be created here. But they're also able to be managed here and accessed here as well. So you've got a sort of a single view of your integration landscape, as it were. So you can see here I've got a couple of other components that we're going to be looking at as well. So I've got my API lifecycle management. I've already got that open. I've got an event streaming instance. So the event streaming instance is going to be the source of my Kafka events. Event streams is an IBM implementation of the Kafka protocol, Kafka standard. Important point to note, when I say IBM implementation, we don't change the Kafka, so it's the open source Kafka that you download. We don't fork the code and put a few IBM comments in the code and then compile it again. We put it in unfettered, as it were. So let me open that event streaming UI. Sorry, I've got some multifocals on here. I'm just having to move my eyes up and down. So this is our IBM Event Streams interface. So we'll visit this a bit later when we're actually interested in looking at the details of the implementation of our particular topic that we'll be interested in. I've logged into the API Manager. I'll just show you a few moving parts in there, and then we'll actually go into the actual demonstration itself. So here's where I can develop my APIs and products, which is what we'll be doing. I can also do things like manage catalogs. So I've got a couple of catalogs created. One called Sandbox, which is the one that actually comes when you stand up an API management instance, something you can use straight away, get you going. And I've got one called my Async Dev catalog. And the thing to understand here is because we've got different gateway types that we're dealing with here. One is specifically for REST APIs. We stand up a different gateway type for async APIs. A reasonable approach. We're looking at morphing those two technologies together, but right now it was just more straightforward to deal with that as a separate instance. And so, regardless of that, the API management environment understands both gateway types, manages both gateway types, and we then assign specific gateway types to these different catalogs that we have here. Catalogs, by the way, are just a logical way of separating APIs for different purposes. So I might have a dev catalog, I might have a pre-prod catalog, for example, in my non-prod cluster, which we're talking about here. We deployed on a Red Hat OpenShift cluster, just so you know. It's a fully microservice-based application is what we're dealing with in terms of the architecture of the product. So when I say standing up a new gateway service, it's actually just a pod or a couple of pods running in Kubernetes. So that's just a little bit of background. Let's go now back and actually get this API going. So I'm going to go and develop an API. I'll hit my develop APIs and products. First thing I'm going to do is go up to my add button and add an async API from a Kafka topic. So that's kind of where I define the type of API that I'm actually looking for. Okay, so a few things we need to do. We need to fill in some details. So title for the API, let's call it flight info, because that's what this application is going to do. It's going to provide some information about flight delays at Sydney Airport. Not very common, of course. So we'll call it flight delays. I think I've spelled that correctly. Okay, good. We'll leave the version at version 1 now. Now, a very good developer and product manager, if indeed this might be a product manager's role in certain organisations in the API spectrum of who does what, would put in some good detail here. So because what you're going to see, what you see here is what's going to be shown to the people who are consuming the API. But I'm just going to put in a very short thing in the interest of time. Flight delay information for Sydney Airport. Okay. And I'm just going to copy that and paste it into my description as well. But we would obviously create some good solid documentation here. Don't do what I'm doing. Okay. All right. Define your Kafka cluster connection details. So this is the kind of the meat in the sandwich in terms of what we need to do is to tell the gateway where's our Kafka broker. And we don't care if it's, and we're using IBM event streams for convenience sake today. We don't care if it's that. We don't care if it's Confluent. We don't care if you've stood up your own Kafka, open source Kafka implementation internally. Irrelevant. Okay, so it's using standard Kafka connection criteria. So the first thing I need is my bootstrap server. So that's where's my broker, what port and host is it listening on. And so I'm going to use my event streams interface to grab that information. Excuse me. Bit of a dry mouth today. And I'll find that in my event streams interface. So I've stood up an event streams, IBM event streams Kafka 3 broker cluster inside my OpenShift cluster. And I've created, for the sake of the demonstration, I've created a topic, but I wouldn't have done that. I'm consuming this particular service. I'm creating an API from a Kafka stream. I would have had somebody else probably, unless it's quite a small organisation where you're doing lots of different things. I've worked in a few of those. It's interesting, but so you probably have somebody already kind of have created this event stream for you, this topic, and maybe it's not being used internally because it's actually been created specifically for exposing that information to a set of application developers who can write mobile apps for people interested in what time's my flight. Okay, So I go to my topics, and we can see here we've got two. I've got my flight info topic. That's the one I'm interested in. But what I'm actually looking for is how to connect to the cluster. So I move over to the right-hand side here, and I just click on that. And here's some Kafka listener and credentials information. So everything I need to connect is right here in front of me. Now, I might not necessarily, as an API developer, have access to this, by the way. I'm doing this today as part of the demonstration, but this information might just be sent to me or be in a Git repo or in a README somewhere. Because I'm on the same cluster as OpenShift Kubernetes cluster as the Kafka topic and the brokers for my Kafka service, as is my gateway, I can use an internal listener. There are external and internal listeners, so things we expose outside of the cluster. So that gives it a nice qualified domain name that I can access from pretty much anywhere. This is sitting on IBM Cloud, so you can connect to it at will. I'm going to use an internal listener, so you can see there that it's actually just using the the service name and then the namespace and the bootstrap.svc as a kind of a standard internal DNS mechanism that Kubernetes provides for you. So I've copied that, and I'm going to put that into my server. My topic name I know is called flight info, so I'll just save some time and copy that and type that in. Now, a developer will probably be interested in a couple of other things. They're definitely not interested in this, by the way, and I'll make that clear. This is the gateway needs to know this information, not the actual consumer of the topic itself, and we'll see that when we actually go to the developer portal. What I also need to do is get a schema for the message body. So I need to provide the consumer of this event, what does this event look like? I'm supplying an Avro schema so that they can actually compress the data over the wire if they want to do that, and tells them which type of serializers to use to serialize and deserialize the message at either end as well. I happen to have my flight delays schema handy. We'll have a look at that in the developer portal. We won't worry about looking at here. And so that the API manager makes sure it's valid, so it validates it, and then it's okay. We've got that information ready for you. I'll click next, and then what else do we need in terms of security for the API? Well, we're going to secure the API with an API key and secret. Okay. I'm not going to publish it just yet, because I'll show you. Otherwise, it would actually just publish it using a default sandbox catalog, and I don't want to do that. So I click next, and within half a second, so it's generated the Async API definition, so I didn't have to code that myself, and it's created the API. We'll just go and have a look at the API briefly, and what we're going to do here is to then create a product. So a product is a mechanism by which we can publish the API. And so what that gives us is kind of a means by which we can group APIs together for consumption that makes sense. If they're related APIs, it might be called flight services. If we're putting all the flight APIs into something called a product, we might just use that name. And it allows us then to apply security and also something like a consumption plan broadly to that list of APIs in that product. So it gives us a little bit more control over what we're doing. So the information for the APIs here, I'm here because I just wanted to show you that we can go to our code view if you want to, and you can see the actual definition, so the Async API definition. So that's all generated for you using the user interface. You don't have to use the user interface, of course. You can do that yourself and upload that Async API definition, and if it's valid, the API manager will pull it in and create the API for you based on that. Okay, so let's go to our back to our develop environment, and I'm going to create a product. As I mentioned before, a product is a way of grouping APIs. So let me add a product, and I'm going to create a new product, and we'll just give this a title, airline services, for example. I'll just correct my spelling there. Okay, and we'll leave it at version 1. So we can version products as well, for the purposes of pushing them through a lifecycle management, and at some point deprecating one version and exposing a new version, for example. And then it says, well, what do you want to put in this product? So I select my flight delays Async API 2.1, which is on the top there, and click next. And we've got a default plan. So I just wanted to pause here because I mentioned earlier that when you're thinking about consumption plans, when you've got a synchronous API hitting an endpoint, you might want to rate limit that for certain purposes, for example, right? So to stop, overloading at the back end, or malicious attacks, for example. Thinking about an async API, does it really make sense to rate limit an event? No, it doesn't. So what you kind of think about here is, because of the model that we're pushing events out to a consumer, we can't sort of why would we slow that down? We want them to get the very latest information that's available on that particular topic, consume that, make it useful in their application. You don't want to get a flight delay event, 15 minutes too late, for example, and you're already down there lining up, and you have to go back to the Qantas Club or whoever we were flying with, maybe, or back to the cafe. So you want timely information. But for some protocols, it might make sense. And there's kind of a body of work going on at the moment back in the IBM labs around what sort of plans make sense for which sort of protocols, and that's still a little bit of ongoing work. But right now, within the product, we don't have any sort of limitation. We don't put any plan limitations on events because it just doesn't fit the model particularly well. So I'll click next, and I've got a couple of choices here, setting visibility and subscribability. So I want to authenticate subscription, which means that when a developer comes to the portal, they need to log in, they need to be identified before they can actually consume my API. But I want the API to be consumed by anyone, in this case, so public visibility. Right, that was it. So we've created a new product. We've got a bunch of APIs. We've added our API into that product, and we've also added that default plan, which in fact is not going to do much for us. Right, so the only step now that I have to do is to publish that API. So right now it's wrapped up in a product, nice and neatly, and it's ready for publishing. So I just need to choose a gateway service to do that too. So let me select my airline services, and I'm going to publish that. Okay, so I'm going to make it visible in the async dev catalog. Okay, so when we define catalogs, we also define a developer portal, which is stood up by the manager when we request it for a particular catalog. So that's a nice way to sort of separate, physically separate really the consumption of APIs. So you might have some APIs that you want to publish to an Azure gateway. We've got if you've got an API Connect gateway stood up in Azure, for example, for the Azure applications, you might want to stand up another API gateway in AWS for your AWS applications for consuming events. Rule of thumb is put the gateway close to the applications. So I'll select my async dev, and I'll select the visibility. That's fine, that's defaulted. And so now that async API is ready to be consumed. So let me just flip hats, and I'm going to go to my API portal. So you can see that the URL kind of gives it away. It's the async dev on the end of that, which sort of steers me to that particular portal. The async dev portal is configured for async API publication. You can sort of put a guardrail in to stop people accidentally publishing different types of APIs, different types of consumption models to different portals. So the first thing I need to do is sign in. I've already registered on this portal. So let me sign in with my credentials. This is a customizable user interface, by the way. We're using the default out of the box. It's based on an open source, the developer portal is based on an open source content management system. And so you can do an awful lot of customization to make that portal look exactly the way you want it to. Let me just remember the password. And I'm using a strong password because you're forced to in this scenario. Hopefully I get that right. So this is the default landing page. When you stand up a portal, as I say, you customize this to make it look like your company's product. I'm exploring the products. I can see I've only got one product here that's discoverable. It's airline services. I click on that and it should take me to the APIs that are encapsulated within that. I've got my flight delays 1 API. Now let me drill down into that. So here, this is exactly the same developer experience, by the way, that you would for a RESTful API. Nothing's really changing. It's a different type of API. You can see there, got some information there about it. It's an async API that protocols Kafka, and some endpoint stuff and some stuff that we'll grab, in fact, for our test application in a minute. But here's where I discover it. And so if I drill down further into my subscribe operation, how do I consume this API? Well, Mr. Developer, we've got some samples. So if I want to, use a Java application, that's my sample code for that. If it's a Kafka JS application, which is the one we're going to do today, here's some sample code for that. And so it's already pre-populated some things. In fact, it's actually a client ID that's come from the client ID that was generated, and I'll tell you how we use that client ID in the actual Kafka API. It's not the same sort of thing that because you put that in a header when you're doing a synchronous call to a REST interface. We don't use that because we don't have that model available to us. It's a Kafka API after all. So I've got some sample code there, which I have actually already taken a copy of, and I've got my payload schema, so I can have a look at that, drill down to that, and understand the actual schema of the message and things that you'd expect: airline code, flight number, origin, destination, boarding, original boarding time, new boarding time, so on. So that gives me enough information to code against the API. However, I still need some things to do. I'll just show you the properties that we're going to use down the bottom of the description, some serializers and deserializers for the Avro schema, so the Avro payload. The bootstrap server, we're going to use that because that's now the gateway endpoint. It's not the broker endpoint. We use that in the description, in the definition of the API, but the consumer of the API is now going to see something completely different. This is now putting those guardrails up that we're talking about to stop. To promote the fact that we're now offering this service, this async API, as a consumable service outside of the environment that the Kafka brokers are actually sitting in. It's somewhere else. But what I do have to do now is one more step, and that's to get access to the API. So this is a subscription point. So we're going to subscribe to the API. So give me some credentials that I need to actually consume it. So let's just do that. And I'm going to use my default plan. Again, in this particular case, plans aren't necessarily applicable. I'm going to select my plan. That sort of starts me off. And I'm going to create a new application in this case. I've got one there called flights. I'll was testing this earlier, so I left that there. This will be called flight delays, or flight, we'll just call it flight info. And that should do us. We don't need to do anything else here, but we just need to give the application a name. And when we do that, I get some credentials. So I'm just going to copy those, and let me just pop those into a little notepad area quickly. So my key and my secret are provided. I can always check what the key value is, but the secret's only provided to me once for good reason, so that it's protected against discovery. Where am I going? Back to my Chrome. So I've created, I've got some credentials, so now I select my flight info application, and I'm sort of going through a little wizard now, so I'm just going to hit next, because I'm going to subscribe just to confirm that that's what I want to do, and then we're done. Okay, a couple of minutes to go. So let's quickly test it. Okay, so I've got some information I need. So the gateway endpoint, I'm going to just flick into a command line environment. That's not the one I want. And I'm going to edit my Kafka code. This is the one that I copied from the developer portal. So let me put in a couple of things. My client ID is down at the bottom here. Let me down here. So I'm going to use that. That will identify me as the consumer. And just go back like that. My broker URL, I'm going to copy from my portal as well. And I've already got, oops, let me just do that again. There is a P missing. Oh, there's actually. Yeah, thank you. I love this. I love this crowd. Thank you. That would have been a little oversight. Maybe try that again. And I've actually now got. Maybe just undo that again. Sorry. Right, broker URL. That looks complete. And so now we're looking at the Kafka API. So there's, we've given a client ID and a secret. What we're actually going to do is use that in the SASL, so using a plain text, because we're in a secure environment between the gateway and the Kafka brokers. So we've chosen not to do that. We're still using TLS, but we're not encrypting the password, username and password. So we're going to use the username and password. And we're going to provide it the client ID and, the API key and secret that we copied earlier. So let me just grab that. And we go back to, oops. I'm probably running over here. My command line, sorry. All right, and we'll input that value. Looks correct, and we'll grab the other one. And so put my password in. Pre-populate the topic values. I'm pretty confident that that's the correct information, so we're going to save that away. Now we're already published, so hold your breath. And we'll just test that. All right, so we've connected to the gateway. And we can see we've been assigned a consumer group, and we're the leader of that because there's only one in that consumer group. And we'll quickly send a message. I've got a little integration running in App Connect, converting an HTTP request into a Kafka publication, and voila. Okay, so from 0 to Async API in a roughly 20, 25 minutes. I did a lot more talking than you probably would when you were doing this, but I just wanted to wrap that up. So what we've seen today is a Async API specification being created by the API manager. I'm sort of interacting with that. You don't have to use that. You can use a developer toolkit, which you can download from the API manager and put it on your workstation and go away and do your work and come back and upload it. We created, we published that API. We published that API into a product, put it there into a product first, then we published it, and then we, as a application developer, different hat, We consumed that API. We ran a sample application that was provided for us, and we tested it successfully. I'm done. Any questions?
What all policies can you add onto into the plan?
So right now, nothing. Okay. So there's because that we were talking about that consumption model for consuming messages off a topic. We're still kind of working out, and what we do here is because this is a relatively new product, we're working with a lot of organisations to actually make this work for them as well. So we're looking for input from the broader community, and so that sort of question, somebody in the labs has probably thought about that more than I have, and so we can answer that for you through those avenues. But right now, no other restrictions in the plan. Yes.
So how does this help Socialise then? Is it just by having a list of what exists in one place? Is that the...
So the socialisation is by when you publish the API, you log in to a known location at the developer portal that supplies to you, and those APIs then become available through that portal. So when I logged in, it wasn't obvious that there'd be a list of products and a list of APIs there that you'd actually probably see in that portal. It wouldn't just be one. And so that's kind of the socialisation aspect. The fact that you can read the documentation and consume that API based upon the information that's given to you. Does that make sense?
Yes. How do I discover there's a cool API that I want to, Async API that I want to subscribe to?
So, well, through the developer portal locations that you kind of discover by organisations sort of saying, here's our APIs, and so you go to the organisation's website. If you want to consume, flight delay information, then here's our developer portal. Click on the link, sign up, and knock yourself around. That kind of thing.
Is there a way to automate the creation of API definitions?
Great question. Yes, there is. So what I did there in the user interface, we expose a set of APIs, strangely, that you can consume for the API manager. So that's what I was interacting with the UI in order to create that automatically. So everything I did on the keyboard, you can do through APIs. Does that make sense? So
if I'm a DevOps engineer, let's say I'm a DevOps engineer, do you have let's say I'm using a Terraform, do you already expose modules that I can call to create this environment?
So if you're pushing this through a pipeline. Okay, so you would, if the developer, so you're interacting with the API manager. So if you had admin rights, for example, and the developer portal didn't exist, you could call an API to stand that up first. Then you can, if you've got an API definition already, and I'm assuming that's where you're coming from. You code.
Okay, so it's mostly still gonna write a script to make API calls to the resource.
Yes.
The APIs that probably is a resource plane that does all the creation under the covers of all of these components.
Of the components in terms of the product and pushing it through, publishing it.
Yeah.
Well, yes, you could. Because you're not really the objects you're creating really are just the API and the product itself. So you can automate that not necessarily through Terraform because we're not kind of standing up any kind of infrastructure. We're just interacting with the API manager. And so what you would do is effectively it would be a script that would call a couple of APIs, for example, or a block of code that kind of executes, pulls down your API artifacts from Git repo, and then executes on those, pushes them up to API manager and out to the portal. So yes, you can automate that.
There was a ASVC file.
Yes.
Came up.
Adversity.
Yeah. Can you have a quick look over that? How
Yeah.
does it look like?
It's not a industry respected creation. It's something I knocked up very quickly. But let me just go back to the portal. That's where it is. Under references, and there's the schema.
That was it.
That was it. That's it. Yep. So it's just complies to the specification. Has some fields, types, and defaults. I haven't. no default values for a start, right? So if I had a test environment, it would sort of generate the values out of defaults and things like that for me.
What other schema formats do you support?
In the product,
Yeah.
apart from JSON schema, XML schema, SOAP as well. So we can proxy SOAP web services.
What about the protobot?
About what's that?
Protobot?
I've not heard of that.
Proto-buff.
No, not currently, but we look at demand with our customers, and if that's something that people are asking for, you can raise what we call a request for enhancement, and if there are enough votes on it, product management goes, okay, that's the next thing we're looking at. So it's not that you don't have access to those extensions if you want them, it's just it might come in a later release.
You mentioned that rate limiting doesn't make sense for the subscription model, but do you make any representations to consumers about minimum and maximum rates that they're likely to be published to?
You could put that into your documentation, for example. We don't touch the stream at all in terms of we don't actually enforce anything. But yeah, you can put that in your documentation.
You don't tell consumers this will be a trickle or a fire hose.
Yes, absolutely. Yeah. So that would be in the documentation. You kind of put that in expected rates, any outages, scheduled outages, that kind of thing. If you do that regularly. Sure.
So where do you actually find like those policies, your guardrails? Let's say if you want to put a guardrail, not for this particular instance, let's say just normal API, right?
Yes.
Where do you define those, and how do you apply that for that particular API?
Yeah, good question. So you define them in the OpenAPI 2 or 3 documentation, in the OpenAPI 2 or 3 document, so the spec for the API. So you'll have client ID, you'll have OAuth in your YAML stanzas for those particular guardrails, you call them. I'm talking about security, but that's a mechanism. If you're talking about rate limiting, you put that in your plan, for example.
Okay.
When you define it.
So the product.
The product.
Sorry, the product. Thank you. He's the real expert on this. We are over time. I don't want to cause anybody grief in the next session. Thank you very much for your interest. It's been a great debate.